So you are given 0 indexed integer array piles, and where piles represent the number of stone in ith piles and integer k, you should apply the following operation exactly k times, right? So what we have to do, we have to choose any piles, right? This is the array, right, that is given, right? It stores number of stones. Okay, so what we have to do, we have to choose any piles and we have to remove the floor piles. How? By piles by 2. Any operation, right, on the same pile more than once, we can do that, right? So we have to return the possible minimum possible total number of stone remaining after applying the k operations. What we have to do, we have to take float of x is the greatest integer that is similar than equal to x, right? So let's understand this question. Question is given this one, 549 in the piles and k equal to 2, right? So what we have to do, we will do apply uh, piles on 2, right? We are applying operation on piles 2, and we will, what we will do, we will result piles as 54545, right? How? See, actually when we are doing this one, right, this one, right, see what we have to do, we have to apply the operation k times. K times means 2 times at least we have to do. How we will do that? We have to do, we have to choose the piles, right, and then we have to remove from that. How we'll do that? We have to take the floor, right? Piles by 2, we have to do that. Piles by 2 is what? If we will do, if we are choosing this one, right? This one, we are choosing this one. Let's say what we are doing, we are doing piles on this number, right? So we will get the float value what? 9 5, right? And similarly if we apply 0, right, so what will happen at index 0, right? What I will do, we will apply at index 0, right? This is our piles value. At index this one, right, we will divide by 2, right? What at exactly we will get the floor value? We will get 3. So similarly we have to face the piles calculations, right, and then we will do. So what we understood till now, that we have to do, we have to choose the piles, right? We need piles number we have to choose, and then we have to remove, right? So how we will remove? We have to do piles by 2, we have to apply. And how many times we have to do? Exactly k times. Exactly k times we have to do, we have to apply, right? So what is the intuition behind this program, right? So we have to apply the approach that is greedy approach, right? And then we will use the max heap, right? Because intuition is saying at any given step, right, at any step, which numbers should be choose, right? Which number should we use, right? We will choose, we want to minimize the total number of stones remaining, which means we want to maximize the number of stone we remove at each step. So we should choose greedily. We have to choose the largest at every step. Largest, we have to choose largest at every step, correct? So every time we compute an operation, the data changes, correct? We see the data is changing, right? Then we need to find the maximum number again, right? We have to find the maximum number again. So the best data structure for this would be heap, correct? So it allows us to update the data always, and then we will always retrieve the maximum value of that one, right? O log n, that because we used to do that, right? Then we have to compare to, right, and then that will take on, right, because this is just an array, right? So if we'll talk about how we'll implement that, that is very easy, right? So let's what we will do that, if we'll talk about algo, right, we will, what we will do, let's start here, then we will understand. Okay, so if we will talk about algorithm, what we have to do, we have to first initialize heap and piles, right? Heap and piles. So how we will do that? How we will do that? We will take the we will start from here, right? So I'm going to start a heap, right? So we will take a heap, we will initialize heap from piles, right? How we'll do that? We will take heap new, right, and this is what, this is our priority queue, priority queue. Okay, priority queue. And this priority queue will take what? Two value at least we will pass, so that we can easily sort it, right? Let me take little space. Okay, and then we will use like this, right? B minus A. Correct. Wait. Okay. So this is what we are talking about. Correct. So this is our heap. Correct. So we have initialize heap from piles, right? We have to initialize a max heap from piles. This is our max heap. So how we have to initialize the heap, right? And this is priority queue. Correct. So we have to define this is a priority queue. Okay. Priority queue we have to define, and we will say that it will take what? A heap, right? Integer. This is our integer, so it will automatically sort it, right? Now we are initializing a heap, right? This is the first step we have to do. Then we have to perform k times, correct? We have to perform k times, and then we will do float value, right? Float value and the data at the data, and then we will do divide by 2. So actually, and at this step we will pop the maximum element from the heap, and we'll call it current, right? So if we'll take a for loop, right? So how we will traverse each value, right? So we will take each value, that is called our num, right? We can say num, and then we'll take from what? Piles, right? This is our piles. So here what we have to do, we have to take the heap, and then we have to add on the heap. So it will automatically add all number onto there. We are doing adding here, right? And for that what we have to do, we have added all the value, we have initialized all the value on the heap. This job is done. So at the step 2 we have to perform the k times, right? So what we have to do, the first we have to pop the maximum element from the heap, and we have to call it current, correct? So for that what we have to do, we have to take a loop. Any loop you can take, but make sure you will have to pass the index, right? Equal to 0. We will start from 0, and then we'll take I less than what? K. Number of times we have to repeat. We have to repeat number of times, correct? We have to repeat number of times. Now we have to do I plus plus, and then we'll start with here. We start with what? We have to initialize a current, right? We have to take a current. So we have to take current. We have to take current, and current is what? Heap dot. We have to remove from heap. Heap dot remove. The max value what will come here after the sorting, that will remove, right? And we have now current. Now we have removed, right? So what we have to do, we have to take int what we have to remove, correct? So remove is what? We have to take the current, and that by 2, right? That it is already given, right? How to do that? Now again we will add this. After removing, we have to add at what? Heap, and that is what? Current minus, we will take current minus remove, right? That we are doing here, correct? After that, if you'll see that we have to check the all the values, right? Not here. We have to go outside, and then we will take one int answer. Okay, we will take an answer, and that is what? 0 we will take, and then we'll check for all the heap element, right? So we'll take a one by one number from where? We will take from heap. We'll take from heap, correct? And then we will do answer plus equal to what? Num. So now we have the sum, right? This should be the maximum sum, right? Because see, initially what we have to do, we have to increase the we have to initialize the heap, correct? We have to initialize the heap from piles, and that we have did. From the piles we are adding onto the heap that we have initialized. Second, what we have to do, we have to pop all the elements, right? We have to pop the all the elements, and that we can say that that is our current. We have to call it as current. Then we will calculate the remove, right? How many stone we have to remove and should we remove from the current, right? That we have to do. We have to current by 2 means half of the stone we have to remove from the current, and that we have did here. After removing we have to add again, right? So we have add again, correct? So each time we have to calculate how many stone we have to remove, we should remove from the current, and after performing the current, it is the floor of the current by 2, right? That we have did here, right? And after we have to push current minus remove onto the heap, and then finally we have to return sum, right? The sum should be what? Sum of element of the heap, right? Sum of the element of the heap, that you are seeing that all the elements we are doing sum. And after that, after completing this, what we have to do, coming after the for loop, we have to return this, right? And this return is what? This return is our answer. Why? Because the final step is saying we have to return what? We have to return the sum of elements in the heap, right? What is the sum of the element, correct? So if we will talk about time complexity. If we will talk, we have talked about time complexity. Then what is the time complexity? See, we are arranging a array. So an array can be converted to a heap in linear time, right? And that will take our what? Our take on. Sorry, that will take our on, correct? An array can be converted to a heap in a linear time on using a method. Will take heap high anything, right? But after converting the input to heap, we have to perform k heap operation, and each k heap operation cost is what? Now is, we can take like this, log n, correct? We know that. And so that time complexity will be what? O and then n plus k log n, correct? We don't know how many operations we have, right? So these operations should be multiplied with, because number of times, right, we are doing, and this time we are doing 2, right? Then if number of k is that, we have to do k into, correct? I think you understood. And another, we have a space complexity, right? A space complexity, and that is what? See, heap's length is equal to n, correct? And we, which is our extra space we have used, right? And that's why we will take O of n only, right? So let's compile the code. Yeah, now we can submit this code. Yeah, working. Thank you so much, guys. So if you have any doubt, please ping me in the comment box.